Hey everybody, this is Larry. This is day 10 of the Leetcode Daily November Challenge. Hit the like button, the subscribe button, join me on Discord. Let me know what you think about today's farm. We have, today's Sunday, so another way to say it is I have 51 weeks until the next marathon, so just kidding. But yeah, it's been a weird week. I'm still so tired. My body's still healing and all this stuff, recovering. I am still just like very tired, even though I didn't do that much. I walk around just for active recovery, but I probably am just very tired. No intro today. It's very rainy here in New York City. Earlier anyway. So yeah, just trying to stay in, clean up my apartment, and just do all the little things, including this farm and maybe the contest later because I think I'm behind on the bi-weekly or something. But yeah, I'm just feeling a little tired. Also, I've been watching the new show. How do you say Pluribus? Pluribus? Let me know if you're watching it though. It is very intense. A sci-fi movie. No, not movie. A series with Seahorn and by the people who did Breaking Bad. So I'm trying to figure out. Pluribus. Anyway, let me know in the comments because that is pretty intense, and I'm curious whether like people watch it. All right, let's take a look at today's problem. We have 3542 minimum operations to convert all elements to zero. They love converting everything to zero these days. I don't know if they're the same problem if I've done it or whatever. I mean, I've done it at some point, but I just don't remember it. Anyway, let's look at it. We are given an array nums of size n of non-negative integers. Your task is to apply some operation so that all elements become zero. I mean, okay, that is the name. Okay, in one operation, choose a subarray and set all occurrences of the minimum non-negative integer in that subarray to zero. All occurrence of the minimum. Okay, I'm just trying to figure out why wouldn't you just keep on selecting everything? Oh, Oh, because if you have a zero, I see. Because you have a zero, you get this, but then now you cannot choose everything again. I think I totally thought that. Okay, minimum non-negative. All right. What is there to say? I mean, I think this is one of those problems where there is this idea of greedy, right? And what I mean by that is that okay, let's say you look at this array. You know that you have to do this one, and if you do this one, then you have to do this one, right? I mean, well, you don't have to, but you might as well because you get it for free. So then now you do all the minimum, and once you do all the minimum, maybe even look at example 3. Once you do all the minimum, then now you have disconnected chunks, and of course, because there are zeros, you cannot go across zero because if you choose a subarray that contains zero, it would set all the zeros to zero, which is basically a waste of a move. So basically now you're disconnecting them. And I think that's basically the idea, and then you just do it recursively, right? Of course, the tricky thing is that recursively, maybe naively, it'll be. I was just trying to think, like, what is the worst case, right? Well, the worst case is maybe n squared, we're not careful, so I'm trying to think real quick. The idea behind the worst case is that if you're not careful, you have like 1, 2, 3, 4, 5, 6, 7, 8, right? And then now you just take everything, and then now you set this, and then now you have this, and then now you set this, and then now you have this. What is a clean way to think about this? I mean, I think the algorithm is right. Well, the idea behind the algorithm, anyway. Maybe it's not recursive, but then the question is, how do you get the complexity down? How do you get it down so that it is not n squared? I guess that's the part that I'm not 100% sure of yet. Huh. Because you could like keep on. Okay, let's say you do a naive subdivide, right? So then you do like I don't know, 1, 2, something like this. But even more, there's like 2, 3, something like that, right? So then now you take away the 1, so then you have this, and then now you take away the 2, and then you do recursion, and it's gonna be a little complicated. I'm just getting water. Maybe we can think about it in reverse. That's my other idea. It's okay. We look at this 3, and we look at all the 3s, right? Well, we look at all the 3s. We know that they're not connected. So that means that, you know, they have to be done separately. And then as a result, you can just remove it. Like, you know that you'll later remove it, right? And then now you look at all the 2s, because we removed all the 3s. Well, we know that we're going to remove anyway, with no regards. And then now you just remove the 2, right? And then now you can remove the 1. I guess that's probably right. Yeah, I mean, I'm trying to think how to implement it. Maybe as a stack, maybe as something. I think I have some idea, but it seems kind of crazy. So I'm trying to write it today. But I think the idea is that, yeah, I think that going backwards is the idea that I want to do. It's just that, you know, for example, if this 3, if it is connected to another 3. Well, I mean, you do it backwards. So by the time you process the 3, all the bigger numbers are down. So basically, that means that if you have strings of 3s, then you're good. But if you have any number, well, all the numbers that are not 3 are going to be smaller. So then that means that you have to separate them, right? I mean, I know a way of doing it, but it just seems so kind of complicated. I mean, maybe not. But all right, I have a crazy idea. We'll see if it works. I think it's still the same-ish idea, but it's just I don't know. But the idea here is that we just kind of, for every number, we just process them by looking to see if the next number on the list is next to it, right? So we'll use, I think I'm going to use a sorted list for this. But what I mean here, right, is that, so we have for index x in nums, right? Well, enumerate nums. And then what we want to add, we want to just add index x. We want to sort by the index. We want it in that order. But the reason why we have a sorted list is so that we can get the next element quickly. I guess it doesn't really have to be a sorted list. It actually could be, you could actually use a linked list. Let's use the linked list actually. I think that's more elementary. Yeah, and then here maybe we just have a node, right? Do I need it to be double? I always, if I have doubts, I always just have it in a double linked list, because why not, right? So then now we have for x in nums, right? We also want to do maybe some lookup, right? Yeah. And then now maybe we have a head is equal to node -1, current is equal to head. Right, so then for every node, we say we do current dot next is equal to a new node with the value x, right? And then current dot next dot previous is going to be equal to current. I just pointed out, and then that's it for this for the node. Current is equal to current dot next. We update, but we also want to do lookup of x is equal to current dot next, right? Because that's the node. I guess I didn't need index. I think I just kind of right. And actually, before I write more code, let me visualize it for you. What I'm trying to do, because I am struggling. I mean, I wouldn't say I'm struggling, but I think I'm like still grasping the idea of it. Oh, this is from another one, obviously. But I am just trying to kind of connect the pieces. But the idea here is that, okay, let's say we have what we said, like 1, 2. I guess I should choose someone like this, right? And maybe you have like 3, 3, just for whatever. And then now we connect it with a linked list, right? And this is a double linked list, but clearly I'm too lazy to draw all the arrows, right? And then the idea here is that we have a lookup. For example, do we have a list of lookups for for 3 we point at here, right? And then my intention is that for each node we just look at the next node, and if the next node is the same number, then that means that you can delete them together, and so then you just delete this one, right? And I mean, you want to delete both of them anyway, but it's just that, well, now if they're the same, then I guess you actually delete. Let's just say you delete this one no matter what. But if they're the same, then you don't need an extra move, and then you kind of basically go this, you move this, and then this, and then basically after all that, keeping in mind that you also remove the linked list, and now you basically have a compressed thing of here, and then now you remove the 2s, and then you have 1, 1, 1, and then now you can remove the 1s happily, right? That's basically what I'm trying to do here. With this code, probably should have explained it a little bit clearer first, to be honest. And that, yeah, this is what I'm doing with the linked list, right? And if you want to play around with just learning data structure, you could figure out how to do it with sorted lists as well, and see why I was going in that direction. All right. So then now we have for x in lookup.keys, but sorted, right? But in reverse order, biggest first. Then now we want to say lookup of x is a list of the nodes, and we remove one at a time. Let's say we have a total operations equal to 0, right? So then, okay. So for node in this, we go, okay. Oh, wow. Gotta turn up my sound. I have some random trades going. Oh, stocks are up today. I guess that's what the ping is for. Not bad. Okay, anyway. Future, in case you're wondering, futures markets is open, even though it is Sunday evening. Anyway, okay. So if we want to we always want to delete this node, but if the next node is the same, then we don't increment total because we just delete them together, basically, right? And you just have to count once, that's all, right? If node.next is not none and node.value is equal to node.next.value, then they are the same. Otherwise, so if this is not true, you could use modus totem too, maybe, or De Morgan's. Then we increment by 1. Okay, and then now delete this node, right? So delete this node. Next.previous is equal to node.previous. Node.previous.next is equal to node.next. And that's it. That should be good. Hopefully. Let's run it real quick. Node is not iterable. Oh, this is a list, but I set it to an item. Whoops. Alright, none type. Oh, node.next is none, of course. Oh, okay, fine. Just for 6 consistent symmetry. Alright. I mean, this looks okay. I mean, obviously not 100%. Oh, because we don't. I don't do zeros because you don't have to do an operation for 0. So that, you know, yeah. Okay. So if x is equal to 0, we just say we continue. I forgot about handling that. All right, looks okay. Let's give it a YOLO submit. Am I 100% confident? Probably not super confident, but I am. I think the algo is okay, but I'm just worried. Maybe my implementation's a little sloppy, which is very possible because I'm kind of lazy. But yeah, so that's it. Apparently it works. 20, 50 day streak. Yeah. What's the complexity here, right? Well, it's going to get dominated by this sorting because it's going to be n log n. But everything else is linear time, linear space. So I'm pretty okay with this. I'm curious what I did last time. Apparently I did it much. I mean, okay. I would say there is another way of doing this. And the other way of doing this is instead of using I mean, there's a sorted list, but you can also use 2 arrays instead to kind of point at the previous and the next index instead of using linked lists. But I'm curious what I did. I don't know what I did it. What? Huh. Apparently previous Larry is smarter than me, so I watched that one from just 5 months ago or 6 months ago. I guess this is the... Actually, I was kind of thinking along this line, but I couldn't quite articulate it. And the reason why I was thinking along this line is just because of what I was saying about merging, right? I was like, okay, well, if this is not equal to this, then we kind of merge. But if we have something like this, then we actually do merge, right? Until it is no longer. And then here we can merge with 3, right? And then with smaller, then we have to remove anyway. I guess that makes sense. And that is obviously better. But I didn't want to make that reduction, but maybe I saw it better last time. I don't know. Huh. I mean, definitely watch that video as well. I mean, I kind of glanced over it. It makes perfect sense because I was having feelings along that line, but I didn't know if I wanted to go down that way. But it also shows you that, you know, there are many ways to solve this thing, even if mine's a little bit not as optimal as that one. But yeah, hope it's insightful. And the other video is only like 4 months ago, so I'm sure it is fine. But yeah, that's all I have for this one. Let me know what you think. Thanks for watching. And yeah, stay good, stay healthy to your mental health. I'll see y'all later and take care. Bye-bye.